Alright, so in this video, I just want to quickly go about not necessarily using the library, like I want to actually write some code. I'm just going to sort of go through the main. So I'm on the master branch because this also has comms code in it. Because if you run, for instance, if we run the emulator, if you look at the terminal here, all of the stuff that's getting spit out. Now this is just essentially demo code that's testing all of the different types of communications, some TCP stuff there, we have some message queue, like MQ, and also some UDP stuff there going on. And so this is just the code I'm going to go through explaining how all of this spam was created, right? So the all of the async IO stuff documented in the documentation, along with all the other stuff in this async IO API. Now in here, there's a bit of a description of it, how it works. Yeah, I mean, this should hopefully make sense after my last little video. And it has a much smaller API than like some of the other guys. Like the entire API has these few functions. And so it shouldn't be very tricky for you to get reusing. Just that the whole concept or something that you're going to be sort of be exposed to maybe for the first time now is the use of function pointers and how function pointers can be passed to certain things to create callbacks. Now, one other place that you might have found this if you actually went into my TUM ball sort of demo API, which maybe might be useful to you in the project, was that I also created these ball objects where I attached, I wonder if I actually have the struct ball. So I actually created callbacks that I embedded into the object, and this callback is essentially just a function that's called at certain times. So when this ball hits a wall, the callback gets called if it's been set, sort of thing. But this is not really part of it. Look through this on your own time. This is some demo code that I use for another thing that it might help you with this project. But the whole idea of a function pointer is that everything in C is an address, right? So a function is stored somewhere in your project, like in your binary at a certain location. And so nothing's going to stop you from saving this memory location as a pointer, like as a variable inside of some structure. And so what you can do then is, like, for instance, you can have, I think I have a pretty easy to understand example. C code snippets state machine. So this is an example that I wrote about for a state machine. Oh, it's not in there. It must be in the... So in my state machine, I have a structure that looks like this, right? And so these four function variables here are actually function pointers. And so you can tell they're a function pointer because of like this bracket asterisk syntax. You'll see it also over here as well. There's this bracket asterisk. So the asterisk is sort of showing, hey, it's a pointer, and this bracket is sort of like saying it's a function pointer, right? Similarly, the function pointer has to have a certain sort of like has to say, yeah, this is the arguments that it takes, and if you have a function pointer, you sort of are fixing the arguments that it has to take. Now, a really easy way of getting around this is that you sort of take in a void pointer, and then inside of your callback, you can dereference this void pointer to be like any sort of structure. But generally, like for instance, if I know, like this is what I'm doing here with these void pointers, but here I always know that my callback is going to take these things because of things I'll get to in the future. And these are very much dependent on top of Linux's like signals libraries and stuff, right? But going back to my state machine, I have these four function pointers here. And so when I create a new state, for instance, when I create, there'll be, like if I want to create a new state and I'm setting these to 0, then this function pointer is set to null. And so for instance, then I go into my code where I run my state machine, delete state init, and here, state handler task. And so what it's doing, it's saying, if this function, like if the state next function has been set, like if it's not null, then run that function. And so it's really handy. You can have a callback, like you can have a function pointer in an object that's a callback that is only going to get run if it's not null, so if it's been set. So this is why it's really, like, it can be handy, but you have to make sure that you zero out your newly created structures that contain function pointers. Otherwise, there could be random garbage in the function pointer, and you'll try and run some random memory address and you'll have problems. So that's how like a function pointer would work. If you want to find this example, this state machine, it's on my GitHub, and C code snippets is my, I think, the repository. And it's called state machines. So in state machine, so in here, you'll find inside of this sm.c and sm.h some good examples. So I think getting rid of that, we'll see how this function pointers are used. You don't necessarily need to do the actual referencing and setting of the function pointers, as in all of these functions handle this for you. You just pass in the name of the function that you want to set. But it's good to know, for you to know that like what a function pointer is. Essentially, you can set the memory address of a function that should get called at some point in time, right? So if we look into our code, how the basic library works is that you'll have these handles, these AIO handles, and this is when I was talking about this. I did some videos on like pseudo object oriented C, and this is one way that I have created objects, and these objects are some sort of an IO connection, and the handle is the object or the thing that I'm using to reference these. And so if we look at the type def, it's just a void pointer. So what I'm trying to do is I'm trying to take away any sort of ability that the user has to interact with the actual back end of the handle of the connection. So if we look at AIO handle, nothing comes up because the struct will be saved. I can't actually myself remember because I wrote this so long ago. Will be inside of async IO, and it's inside of here, I imagine. So what you'd actually be getting returned is this guy here, which is the AIO structure, which has the callback, the arguments, it's part of a linked list, and then the attributes and all this other stuff that you as the user don't need to know what they're doing. You just need to have a connection that's been established, and then you can use the API to interact with this this thing. So you'll create a connection using OpenUDP socket, OpenTCP socket, and then you can like interact with it, you can close it, you can DNet the whole library, you can put things into the socket. And so this is how I'm trying to abstract away what you can do using this API, this library, right? So now let's have a look where I've used this in this example code. We'll look basically at just the UDP ones. So as you can see here, I'm using my AIO handles. I've got message queue 1, 2, UDP sockets 1 and 2, and 1 TCP socket. So we'll just focus on these two now. So if we're looking here, we've created a handle. Now, one really good thing here is that I'm setting these equal to null, because these are essentially void pointers. But the thing is, if I set them to null statically, meaning that where they're declared at the top of my main file, I can then use checking them if they're still null as an error check. So if I initialize them, but after the initialization they're still null, I know that something's failed. And so I'm not going to try and use a connection that didn't initialize properly. So now we're going down to my VUDP demo task. And so as you can see, this is before the while loop. And so this is where the sort of like the code that's run once is put, and this is where I'm doing my initialization for this UDP socket. And so the UDP socket, if we look at the function, I'm using this open UDP socket. And if we look at the documentation for it, well, very descriptive, it opens a socket endpoint. Now, what does it take in? It takes in the IP address of the target client in IPv4 numbers and dot notation, the port the socket should be open on, the buffer size, the callback, right? And now in this case, if you don't set the callback, nothing will really happen. As I was saying before, like in the state machine, I would say, hey, yep, if there was an exit function, call the exit function, at this certain point in time. But because the whole idea of this library is that you asynchronously call essentially interrupt handlers when certain signals come in, if you don't set the interrupt handler, then nothing's going to happen, and the whole opening a connection was pretty much useless. So in our case, the callback function shouldn't really be considered optional, right? Now, and the arguments, so these are the arguments that are passed the callback. So I'm wondering now if I should probably explain this a little bit better. So if we're looking at, I might just do this quickly. So a function pointer, where was it? So an AIO callback has to take in these two arguments, right? Receive size and buffer. And this is because the receiving calls from like the message queue or the UDP or the sockets will actually return to you the number of bytes or characters or what have you. Like in this case, is literally the number of bytes that are returned, that were returned from the kernel from the receive call. And then this is the buffer where they were stored. So you pretty much know, hey, yeah, this is where my data is stored, and you know how much was stored. But if you want to do some other sort of special stuff inside of this function, you need some way of passing it in, like some sort of abstract data structure with whatever in it that you want. Like if you want to have some sort of account or another buffer to copy it into, you need some way of like not locking down the user to only being able to pass in some certain sort of structure in all of your callbacks, right? So each callback, like maybe you have callback 1 and callback 2, callback 1 will typecast args here to be like structure 1, and then in callback 2 you can typecast it to have the form of like structure 1 or structure 2, right? And so in that you can have a different data sort of layout. So if I'll quickly like just example by X, whatever. It doesn't actually, if we do example, because then I'll get some. So here, like if we wanted to have like some sort of a function, let's take this example. So we'll create two callbacks. Let's just say that these are our callbacks. I wonder if actually maybe I have them in here. UDP handler 1. I don't use them in here. Even better example. I'll use these ones. So we have, as we can see here, we've created the socket 2 and the socket 1, and I've put in UDP handler 1 and UDP handler 2. And so it means that whenever we get a new packet coming in on this first socket, this function gets called. And we have a packet coming in the second socket, this function gets called. They both have args functions, but we can specify, for instance, we can make like a struct sock1 args. Oh, sorry. Int count. And then we can say that, you know, sock2 args. And we'll make this like a char array first. Just make it like a length of 5 or something, right? And so now we have these two different structures that have different actual data contents. So this one's going to be probably like 4 bytes in length, and this one will be 5 bytes in length. So actually different size memory structures in memory. But now it's up to the user to say, yes, okay, in handler 1, args is always actually going to be a pointer to a sock1 args structure. So we can actually typecast it, and we can use, like, there's many different ways of using it, but one nice, easy, clean way of doing it is you create a struct sock1 args pointer. So this we'll call this our casted args. And we'll set this to a typecast of the args pointer. Because it's a void pointer, it just needs to say, yes, like you're trying to say, I know what's at this location, and it is a structure sock1 args. So struct sock1 args pointer of args. And now if I go and use my casted args, I can say, you'll see here that my completion is telling me, yes, this structure has this int, this count I. So I could do something like this. But similarly, I could go into here, which is taking, it's the same callback, it's taking as again args, it's the same function structure, like taking the same function arguments, but inside here I actually have access to different sort of data through this arg because I'm passing in, for instance, sock2 args structure. So I can say struct sock2 args pointer casted args equals struct sock2 args pointer args. And then if I go to use casted args here, you'll see that I am using first chars instead because it's here. And this is the whole idea of having an arguments, a void arg, a void pointer to an args that's passed to a callback, because you're not locking down the user to using a certain arguments for your function. This might be very confusing to some. You won't necessarily need it for this project, but if you have problems with this, approach us and we can help sort of walk you through it, because this is getting to very sort of advanced C. So that's doing that. This is actually not helping us in any way, so I'm just going to actually stash this, get rid of it. So going back to the whole like how it works, we've created these handles, like we've got the two handles, which we have then initialized in here. So we're initializing them here, and this is returning now the populated handle. Now I actually haven't done any error checking here, but what I should have done here is if not UDP sock1, then we have like exit, I don't know, just whatever, because this means here, because I nulled out the handle originally, this means that the initialization has failed. So I really should have added an error checking here, but can't be perfect. Now, so we've given in the handle this address here. Now let's just talk about more what you actually have to pass into this open UDP socket. Now you want the IPv4 numbers and dots notation address. And so you should all be familiar with this, like 192.168, some sort of a local network. Like as you can see on my screen down here, this is my laptop's address on my local home network, right? In this case, in the test stuff, I've been using it to localhost because I'm sending and receiving from the same binary. Now for all of you, because you'll be running this sort of opponent binary in your own machine, I mean, you're free to run it on a separate machine in your home network, go for it. But you're probably all gonna be running it on your own machine, meaning that you use the local host address. So you can pass in 127.0.0.1, or in my case, you can see here in my address, I have my address just equal to null, right? And so therefore, when I'm passing in null, it'll just by default use localhost or loopback, meaning my own machine. Now the port itself uses this import T style. So this is actually a Linux. I wonder if this reference will resolve. Yeah, so this is part of the Linux sort of libraries, and so this is not something you really need to bother yourself about. But essentially, it's just a uint16. So like if I want, like where's this guy defined here? It's just some number, 1, 2, 3, 4, right? And so we'll release to you the ports that that this binary runs on, because essentially you have one port. For those people that don't know, like ports or sockets, what they are, essentially sockets are sort of opened. This to do with the networking, and when internet traffic comes in and out, like you'll have different sockets and different ports. Now a port, for instance, like port 80 is like HTTP traffic. So when you're actually going to an internet address to get the HTTP of it, you're actually by default going to the web server and saying, hey, I'm coming in on port 80, and then some sort of like proxy or reverse proxy will resolve your HTTP request based on the port that you've accessed and the address that you put in and blah, blah, blah. But for us, essentially, we're going to set one port number, or we're going to open a socket and on a specific port to handle like, you to the opponent, and then another port for the opponent to you. So we have like sort of this full duplex TX on this direction, on this port, RX on like a different port going the other way, right? But in this case, we're just sending, we're going localhost on port 1, 2, 3, 4, right? And then this test port is something else. I think it was like 2, 3, but backwards 4, 3, 2, 1 or something. Yeah, 4, 3, 2, 1. So I'm opening here 2 tests, both on localhost, one of them on 1, 2, 3, 4, and the other one on 4, 3, 2, 1. Now, the buffer size here, so if we look, the number of bytes to be reserved for buffer for the connection. Now, the back end of this library reserves this memory for this connection. So when you're sending in, or when you're sending like a string via this library, you're going to send in like, hello world, that's like HELL, like 11 characters plus termination, so 12 bytes of information. And so you're going to want to have a UDP buffer size that can handle this. And so then you're just going to open up, you're going to say, yep, I need to send maximum 12 bytes. So you'll just send it in here, how large you want this buffer to be. In this case, I'm just doing some 2000 buffer size. Now for you, try and be less, just like whatever 2000, because obviously the more you allocate, the more memory, the more overhead it has. But like, don't try and exactly calculate. Like maybe, I mean, you can if you want to be really efficient, but let's say you're only ever sending the X coordinate, which is like a 16-bit value, so 2 bytes. You don't need to allocate 2000 bytes for your buffer, right? You're passing in the handle. So here, how you set a function pointer, there are lots of different methods or like different annotations in C, but they stupidly all do the same thing. So what you pretty much just do is put in the function name, right? And so this will create a function pointer, right? And then args here. So if you wanted to do like what I had before, so how I did before with my soc2 chars, what I could do here is then I could pass in, for instance, create here struct soc2 args equals dot first chars hello. Well, yeah, it doesn't have a termination, no space for it, but you'd have something like this. My soc2 args, and then I could pass this in here. Meaning that when this function gets called, this guy here actually would contain this hello. I've probably got it first chars. It's not liking something. Suck. Anyway, so that's how that works. Now, going back to, I'm going to get rid of this again. Now look at more of the functionality of the API. When we run this, like, so we'll see here, if we actually just, I'm going to stop everything else from running just to get our logs a little cleaner so it's easier to see. We only want to, we'll look at just task 1. So UDP demo task, we'll get rid of the TCP task and we'll get rid of the message queue task, but we need the demo, we need the send task, I think. So we only want to put it into message Q1, no. So we'll just get rid of this. Okay, cool. We'll see here we have the one UDP socket's been opened, and we'll see this tick here. So every tick, this is what's happening, right? We have this UDP receive in first handler. So if we go to our code, we'll see here that this is actually the code that we've got in our function that we passed in as our callback, meaning that the send function here, so if we look at the demo send task, every 1000 milliseconds, so once a second, he's sending is using this call, which we'll go to in a minute, is calling sending test string 1, which is UDP test 1 to that socket. And we can see this is UDP test 1. And so the callback is just printing the receive string, which we can see here. It's printing buffer, which is the receive string, right? So if we look at the documentation, socket put, this will be the sort of the other function that you'll need. And then what this does is it actually sends data stored in a buffer to the socket described by S address and port. So it uses the same exact notation for port and the address. So if we look at, where was it? Oh, no, that was the one. We're using the port, and here we also have null. So I should null for localhost and loopback. So the same thing again, this probably be the same for you, that we want to send to a loopback to the test port for 1, and we're sending it some sort of data stored in a buffer. And so the buffer here, we want to pass it in, the buffer type is a character pointer. And so in this case, we have this character pointer, which is the string UDP test 1, which we're passing in here. And you also need to tell it the length, because C doesn't have explicitly strings, and so you need to know how much data you want to send, just in case, you know, the termination character is actually just some value that you want to send, like you want to send 2 strings in 1 packet. Then you tell it the length, and in this case, I'm just using string length to tell it the length of the string. Right. And so by doing so, then we can also, for instance, do some error checking. So this is something I'm also not doing, not necessarily required because of the whole, as I explained in the last video, TCP, UDP. UDP is just sort of like spamming. And so if it fails to send 1 packet, I don't really care, because I'm just going to send it the next packet, right? I'm not really caring that every single packet was successfully sent. So that's what that function does. This documentation should make it quite clear. We're not using really close connection. It just closes it. Cancels, frees up all the memory and whatnot. It's called in the dinit stuff, I think. So, or it's so I think if I go to this, probably the header file again. Yeah. So what's happening in here in the dinit is it's just going through every single connection that we've opened, which is stored in a linked list, and it's just closing them, which is freeing up and just doing all sort of cleanup stuff. So the whole use of this library for you will be pretty much just to use open UDP socket, and then to use a IO socket put to put data, and then use the callback to receive data that you get, right? So this is what you use to put, and the callback asynchronously gets called for receive data. So this is where it's going to be up to you to sort of like handle this, write a callback that works in terms of multi-threading and real time and blah, blah, blah. So hopefully there's enough for this video. I think now that I've sort of explained the demo, I'm just going to go through and create a really basic example. So something that may be similar to what you guys will be doing in the semester, and see if I can sort of wing this. Oh, the whole thing's been winged. I don't know if you can tell. But thanks for watching, and I hope this helped.